As we start looking at triangles, we need to know how to name triangles. So triangles are named using their vertices. So the vertices are the points where they meet. So this triangle can be named ABC because alphabetical order is nice, but it doesn't have to be. So it could also be like triangle CAB or any combination of those three letters. Since it's a triangle, there's only one way it can go. So if there's more than 3 points, if there's 4 points, then you have to go in the order it goes around the shape. But no matter which direction you go, you'll get a triangle whenever you name it. So the next thing is if we have a right angle and a triangle, then we have some different names for the sides. So here these are all three just sides. Once we get into a right triangle, the thing across from the right angle is called the hypotenuse. We've used the hypotenuse whenever we were looking at distance formula in the Pythagorean theorem. So this is the hypotenuse, and the things around the right angle are called legs. So we can name triangles based on their angles. This is a right triangle. So if we're classifying by angles, we can have a right triangle if there is one right angle. We can have an obtuse triangle if there is one obtuse angle. And if there is no right angle, no obtuse angle, then it is an acute triangle. So an acute triangle has three acute angles. An obtuse has one obtuse and two acute. A right has one right and two acute. So you can't go between these. You can't have multiple names by angles. Now we're looking at something where these markings mean that these sides are congruent. So if we have two sides that are congruent, that's called an isosceles triangle. In an isosceles triangle, the pieces that are congruent are called the legs. And then it can't be called the hypotenuse because the hypotenuse is only in a right triangle. So the other side is called the base. So we have the base and the legs. Whenever we're talking about angles in a isosceles triangle, this angle up here is called the vertex angle. And these angles are called the base angles. So the angles down here, this is a base angle, and this is also a base angle. And that'll be important in the next lesson. So now, whenever we are classifying triangles by sides, we can have a few different names for those as well. So an isosceles triangle has two sides that are congruent. If all three sides are congruent, then that is called equilateral. And then in a triangle where none of the sides are congruent, that is called a scalene. So a lot of times we have to go by markings, like these markings that say that those two legs are congruent. That's how we have to go to identify those in those ways. So you can have a classification by angles and by sides, but you cannot have two side classifications or two angle classifications. So now we're going to go and look at some triangles and start classifying them. So we're looking at some markings. If we have these tick marks on the sides, that means that those sides are congruent. So here I can see three sides that are congruent. And that means that by sides, this is an equilateral triangle. And then I'm going to classify it by angles as well. So looking at these angles, none of these angles look like right angles. So that means that this is an acute triangle. In the next one, we have two markings on the sides that say that those two sides are congruent, but the third one doesn't have it. So that means only two sides. So by the sides, this is isosceles. And then if we look at the angles, none of the angles look obtuse or right, so this is an acute triangle. Now, as we go to the third one, we don't have any markings anymore, so it looks like these could be congruent, but we're not for sure. So if we're not for sure it's not marked, then that is a scalene triangle by the sides. And then by the angles, we have this one right angle, so that makes it a right triangle. So each triangle has a classification by its sides and its angles. So now let's look at some of the theorems that we have in this section. So Theorem 1 is better known as the triangle sum theorem. And the triangle sum theorem says that in a triangle, if you add the three angles up, the three interior angles, the sum is always 180. So triangle angles always add to 180 is the gist of that one. All right, so the next thing is a corollary, and a corollary just means a specific case of a certain theorem. So this specific case is for right triangles. We can call this the right triangle corollary. And so the right triangle corollary says that if you have a right triangle, then the two acute angles add up to 90. So two acute angles add to 90. So this is a specific case because we already know that angle 3 here is 90 degrees. We can take that out, subtract the measure of angle 3, subtract 90 from both sides, and then we are left with what we have here in the corollary. Theorem 6.2 is better known as the exterior angle theorem. And this says that if you have an exterior angle of a triangle, which comes from extending one of the sides. So an exterior angle of a triangle is the sum of the two non-adjacent interior angles. So adjacent means that they touch. See how angle 3 and angle 4 share this ray? 3 is the adjacent angles. So we can't use 3 in this calculation. It has to be 1 and 2. So here's the reason that this one works. We know that the triangle sum is 180. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is going to be 180. We know that linear pairs add up to 180. So the measure of angle 3 and the measure of angle 4 add to 180. So since these both equal 180, I can set them equal to each other. And then notice that there is a measure of angle 3 on both sides. So if I subtract that, here's what I'm left with. Measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. So angle 3 is used in the triangle and in the linear pair. So if we just take that out, those other two pieces are going to be equal to each other. So now we're going to start using these to solve some problems. So first we have find the measure of the exterior angle. So the exterior angle here is going to be equal to the sum of these two interior angles. So I'm going to say 2x minus 11. And then for the sum of the two interior angles, it's x plus 72. So to go about solving this, I'll subtract x from both sides to move it. And then I have x minus 11 is 72. To get rid of that minus 11, I'm going to add 11 to get the x by itself. And here we have that x equals 83. Make sure that you pay attention to what the directions say because it says find the measure of the exterior angle. So now I need to use that x equals 83 and plug it into the exterior angle. So that'll be 2 times 83 minus 11, just based off of this measure that it gave me. So 2 times 83 is 166 minus 11. That will give me 155 degrees. So the measure of the exterior angle is 155. So on this next one, the measure of one acute angle of a right triangle is 1/4 the measure of the other. Find each angle measure. So we can draw this triangle to help us figure it out. So if the measure of one of the acute angles is 1/4 the measure of the other, I want to go for the smaller one and call it x. So if this is 1/4 of the bigger angle, then if this is x, this will be 4x. So the smaller angle is 1/4 the size of the larger angle. We also could have done it the other way where the larger angle was x, and we could have had x up here and 1/4 x down here, and we would have gotten the same answer. It just depends on what you're solving for. So I like doing it this way so that I can deal with whole numbers. And this way, with the right angle corollary, the right triangle corollary, I know that these two angles are going to add up to 90. So 4x plus x equals 90. Then I can add these together and I get 5x equals 90. So if I divide both sides by 5, I get that x is 18. So x is 18, that's the smaller angle. So 18 degrees is the smaller angle. So up here I need to do 4 times 18 to figure out the larger angle. And so the larger angle will be 72. So these two add up to 90, and the larger angle is 4 times as large as the smaller angle.